Assalamu alaikum guys, welcome to chapter 8.9. So today we're dealing with the quadratic formula. Now a quadratic equation is written as ax squared plus bx plus c equals 0. So remember that in the previous chapter we were factoring trinomials and we were finding the factors. Now in this chapter we're using those factors, or we're using graphs to find the zeros of the function, which are your x-intercepts. And we've learned that depending on what the graph looks like, it can have no solution, one solution, or two solutions, and that's for quadratic functions. Now the quadratic formula works for any type of quadratic, whether the ones that you can factor or the ones that you can graph and easily see the solutions. But mainly the quadratic formula, you want to use it for those where you're having a really hard time finding the conditions, meeting the multiplication condition and then the sum as well, or those graphs that go into decimal form as well as far as the intercepts are concerned. So here we go. The quadratic formula is x is equal to negative b plus or minus then the radical of b squared minus 4ac all over 2a. Now the quadratic formula has a lot of parts to it that is useful in finding the axis of symmetry. I don't know if you all noticed that the axis of symmetry, remember in one of our lessons, x is equal to negative b over 2a. So it comes from part of the quadratic formula. Another part of the quadratic formula is whatever is inside the radical is called the discriminant, and we're going to cover the discriminant in a little bit. But the whole formula overall, it helps you find the solutions, the zeros, the roots, the real roots, depending on what the term is used, of a quadratic function. Two very important things. A should never equal 0, because then you're not using a quadratic function. If a is 0, that means the only thing left is bx plus c, and that's a linear function. Another thing is as well, this is called the discriminant. The discriminant b squared minus 4ac has to be greater than or equal to 0 in order for it to have a solution. All right? So if if it's not 0 or it's not greater than 0, then it has no solution. So anyways, let's go ahead and start the first part. This is going to be a classwork assignment. So for today, we have the discriminant. The discriminant of the formula, remember I said b squared minus 4ac. Now, when you use that part of the quadratic function, it helps you determine the number of solutions, okay? So what it means basically is it's the x-intercepts. How many x-intercepts is the quadratic function going to have? So what do you need to know? So if you substitute values, okay, if the answer is greater than 0, then your quadratic will have two x-intercepts, okay? It'll have two solutions. Now this itself is not going to tell you what are those solutions. It's only helping you. How many solutions does it have? So if the value of the discriminant is greater than 0, it's two solutions. If the value of the discriminant is exactly 0, it's going to have one solution. And then if the value of the discriminant is less than 0, then it has no solution. Because remember, since in the quadratic function, the part of the discriminant, b squared minus 4ac, and by the way, we're only using this value, right, or rather this expression, b squared minus 4ac. But remember, when it comes to no solution, if your value is less than 0, in other words, let's say negative 100, remember that we said that you cannot find a solution, or you cannot find a radical to a negative number. So that's why, we said that the b squared minus 4ac has to be greater than or equal to 0 in order for a quadratic to have a solution or two. So you're going to be using the discriminant, and you're going to only determine the number of solutions for the first part. So your instructions are determine number of solutions. And remember that we're using b squared minus 4ac only, okay? So let's say, for example, our first problem is going to be 3x squared plus 8x plus 7 equals 0. So you're just determining how many solutions will this have. So remember, b squared. And you've got to remember that our values are, this is my a, this is my b, and that's my c. Okay? So b squared, so that means 8 squared minus 4 times the value of a, which is 3, and then times the value of c, which is 7. So 8 squared is 64, right? Then if you go ahead and take the calculator, basically consider -4 times 3, -12, times another 7 is going to be -84. And then 64 minus 84, your answer is -20, right? So if your answer is -20, what was the condition? If the value is less than 0, then it's no solution. Okay? So this problem has no solutions. If you were to graph it, it's never going to touch the x-axis. Let's try another one. How about if we have x squared plus 2x minus 3? Okay, so remember, we're using b squared minus 4ac. Our b is 2, so 2 squared minus 4, the value of a, the invisible 1. And then the value of c is -3. And you do have to keep track of negatives, guys. So in this case, 2 squared is 4. And then -4 times 1 is -4. -4 times 3 is +12. So in this case, my value is 16, right? So the value is greater than 0. Therefore, I have 2 solutions for this. Okay? So this is how you use the discriminant. Let's try a couple of more, because it's not always going to be looking like the way I've been setting it up, right? Sometimes you might have to rewrite an equation or an expression. Sorry, guys. Sometimes you have to rewrite the expression, make sure that it is written in standard form, so you can be able to pull out the values that you need in order to solve. So here we go. Here's another one. How about if we have, for example, we have 4x squared, and then plus 20x is equal to -25. Now, this is not written in standard form. Before you can apply the discriminant, it has to be, the equation has to equal 0. So the first thing I need to do is I need to add 25 to both sides. So I'm going to have 4x squared plus 20x plus 25 is equal to 0. Now I have my a, my b, and my c. So b squared, my b squared is going to be 20 squared minus 4 times a. My a value is 4, and then my c value is 25. And then go ahead and do the math on it. So 20 squared is 400, and then -4 times 4 times 25, plug it into the calculator, you should get 400. Now the value is 0, and if the value equals exactly 0, what does that mean? One solution. All right. And then the last example for the discriminant. Let's say that you have 2x squared plus 5x equals 0. Now notice in this, it doesn't have a constant. So you can assume that you have the plus 0 there. That's going to be your c value. So when something is missing, then the value is 0. But remember, we did say that the leading coefficient cannot be 0. You have to have a leading coefficient, whether it's the invisible one or a -1, but you can never have the leading coefficient be 0, because then it would be a linear equation. So again, in this case, b squared minus 4ac, my b value is 5. So 5 squared minus 4 times a is 2. And then times c, the c is that invisible zero, or the zero that we don't see, because you assume that if there's no value there, you're not going to put a number other than 0. So times 0. So 5 squared is 25. And then negative 4 times 2 is negative 8, times 0 is 0. So minus 0. Final answer is 25. So in this case, if you were to graph this equation, you're going to have 2 solutions. Okay? So this is basically the gist of just determining how many solutions does a quadratic have if I use the discriminant. And that also helps you kind of like test, you know, if you're trying to find the solutions and you're having a hard time, whether you're using the quadratic function, whether you're factoring, test the discriminant. The discriminant, more than anything, especially, obviously you have to keep track of negatives. You have to do the math right. But when you use the discriminant, it basically tells you this equation is going to have a solution, it's going to have 2 solutions, or it's going to have no solutions. So this is why we use the discriminant for, okay, or what we use it for. So now the next part of the lesson is how can you use the quadratic formula to help you solve and get the solutions without graphing, obviously, okay? So remember, the quadratic functions, or the quadratic equation rather, was x is equal to negative b plus or minus radical of b squared minus 4ac all over 2a. So this is the formula that you're going to be using. So now let's say, for example, I give you 2x squared plus 7x is equal to 9. Now remember, this also plays like the discriminant. You need to make sure that the equation equals 0. So go ahead and subtract 9 from both sides and make sure that when you rewrite it, it's written in standard form. So on this example, 2x squared plus 7x minus 9 equals 0. Okay? And don't forget, what's my a value, b value, and c value. Now we're going to go ahead and use the quadratic function. So I'm going to be using this. I'm not going to rewrite it again, but x is equal to negative. Now my b value, and I'll label the a, b, and c on this. So this is a, b, and c. Make sure that you keep track of negatives, okay? So negative b, and my b value is 7, plus or minus the radical, and b squared. So again, 7 squared minus 4 times a, my a value is 2, and then times c, my c value is negative 9, all over 2 times a, my a value is 2. Now all you have to do, and by the way, when you're using the quadratic function, guys, it's actually giving you the solutions. What are the final solutions when you graph? So go ahead and start doing your PEMDAS. Now here, negative 7, keep track of it, plus or minus. Now inside the radical, 7 squared is 49. And then you have negative 4 times 2 times negative 9. It should give you a positive 72. On the bottom, I have 2 times 2, which is 4. Okay? The next step, go ahead and start simplifying your radical. Now you have 49 plus 72. 49 plus 72 is 121. And then after that, bring your 4 down. Now right here, we know that 121 is simplified form is going to be what? 11, right? Because 121 is a perfect square. So x is equal to negative 7 plus or minus 11 over 4. So now here, remember that we have that plus or minus, so we can separate and make 2 different statements. I can say that, and let me box this off so I can not confuse you all. One of the statements that I can say is x is equal to negative 7 plus 11 over 4. Or I can say x is equal to negative 7 minus 11 over 4. And then do the math, okay? So remember, this plus or minus, you split it into a plus and a minus equation. That means that this quadratic is going to have two solutions. So first of all, negative 7 plus 11 is negative 4, right? So here, or rather positive 4. Negative 7 plus 11 is 4. Don't forget that that's over 4. Simplify that. X is equal to 1. So that means that when you graph this equation, one of the x-intercepts is going to be positive 1. On the other side over here, we have negative 7 minus 11, that is negative 18 over 4. So x is equal to negative 18 over 4. And just go ahead and simplify. You don't have to put it in decimal form, but put it in, even if it's an improper fraction, just simplify it as much as possible. Both of these numbers are divisible by 2, so x is equal to negative 9 halves. So your solutions, x is equal to 1, or the other solution, x is equal to negative 9 halves. Now, negative 9 halves on a graph would be what? Negative 4.5. So, inshallah, you found this easy. And let's try one more before I leave you to actually work on it by yourself. Most importantly, guys, make sure that you keep track of negatives. Make sure that before you start substituting values, that your quadratic equation is written in standard form and that it equals 0. If it doesn't equal 0, force it to become 0. So let's see this one. What about if we have 3x squared minus 1 is equal to x? Again, like I said, make sure it equals 0. So the only way I can make it equal 0 is if I subtract an x from both sides. Now here, make sure it's written in standard form. So 3x squared minus x minus 1 equals 0. So remember, what is my a, b, and c? So a, my b is going to be a negative 1. My c is also a negative 1. Now, using the quadratic function, this one right here, x is equal to negative. And then my b value is negative 1. So put it in parentheses so you don't lose track of it. Then plus or minus the radical. And what is our b value? Again, it's negative 1, right? So we're going to go ahead and square that negative 1. Make sure that you put it in parentheses. If you don't put it in parentheses and you use your calculator, it's going to give you the wrong value. And then minus 4 times a. A is 3. C is negative 1. And then all of this over 2 times a. And the value of a is 3. Okay? So now let's go ahead and start doing our math in it. X is equal to double negative 1 plus or minus. Now, negative 1 squared is 1. And then you've got negative 4 times 3 is negative 12 times a negative 1 is a positive 12 all over 2 times 3, which is 6. So now we're at x is equal to 1 plus or minus radical of 13 over 6. And you can go ahead and simplify that radical of 13. And the radical of 13 is approximately, and for questions like this, the instructions, especially if it goes into decimal form, it'll probably tell you to the nearest hundredth, okay? So we're going to go ahead and answer to the nearest hundredth. So if I do my math on the side, okay, and I am asking for the radical, and I'll put it up here, radical of 13, the radical of 13 is approximately 3.61, okay? So we can go ahead and make the statement now. X is equal to 1 plus or minus 3.61 over 6. And now you can go into your two statements and say, I'm going to section it off. X is equal to 1 plus 3.61 over 6. Okay, go ahead and do the math. So if I start solving this one right here, I'm going to end up with 4.61, right? Which is equal to 4.61 over 6. and then go ahead and divide, and you should get x is approximately 0.77. So that's one of them. The other one is x is equal to 1 minus 3.61 over 6, which in this case, it equals to negative 2.61 over 6. And if you go ahead and plug it into your calculator, now depending on the rounding of your calculator, so let me go ahead and just double check on this one. 2.61 divided by, or negative 2.61 divided by 6, you're going to get to the nearest hundredth approximately 44. So we can say x is approximately negative 0.44. So you can see that if you're trying to factor this type of quadratic, there's no possible way you can meet the conditions of the product and the sum. So you're going to have to use a quadratic function. There are ways to solve it on a graphing calculator, guys, by using the tracing method. But let's say that you don't have a calculator and you need to be able to find the zeros of a function, especially if you're taking TSI. Then using the quadratic formula, you can find the solution. So the x-intercepts for this, it would be a positive 0.77 and then also a negative 0.44. So if you have any questions, come to math class, and inshallah you found this lecture easy. Assalamu alaikum.